On this accord, P0172 means the ECM/PCM is seeing the fuel system running too rich. In plain language, the computer may be pulling fuel back because the mixture looks heavier on fuel than expected. The driver may notice a check engine light, rough running, poor fuel economy, or a fuel smell, but it can also show up with very little complaint. The broad areas we're thinking about are fuel delivery, fuel quality, airflow measurement, crankcase contamination through the PCV side, air/fuel sensor feedback, and injectors. Before you start, save the captured operating data. Do not clear the code or reset the PCM yet, because that can erase useful diagnostic information. Also look for aftermarket fuel system or engine parts before getting deep into testing. And if other codes are stored with P0172, check what they mean first. Then come back and recheck P0172. Start by verifying the problem at idle. Start the engine and let it idle with no load. On an automatic, leave it in P or N. On a manual, leave it in neutral. Watch AFFB or short-term fuel trim on the HDS. The key line here is whether AFFB is less than 0, 79. If it is less than 0, 79 at idle, the rich correction is happening right now, so move on to the low-pressure fuel check. If it is not less than 0, 79 at idle, do not force the test at the wrong condition. Use the captured operating data next. If idle does not reproduce it, use the captured conditions. Look at the moment where AFFB was at its lowest point and record engine speed, vehicle speed, relative throttle position, and accelerator pedal position. Then drive the vehicle under those same conditions and watch AFFB on the HDS. Again, the decision point is whether AFFB is less than 0, 79. If it is, continue with fuel pressure testing. If AFFB is okay under those same conditions, the system is normal at this time. Once the rich condition is verified, check the low-pressure side of the fuel system. Start the engine and let it idle, then check fuel pressure under the same condition where AFFB is 0, 79 or less. The expected low-side pressure is 390/440 kPa 404. 5 kgf/cm2, 5764 psi. If pressure is in that range, keep going to the high-pressure side test. If it is not in that range, replace the fuel tank unit. Next, check the high-pressure side. Turn the ignition off, then back on. Clear the DTC with the HDS at this point. Start the engine and hold it at 3,000 RPM with no load until the radiator fan comes on, then let it idle. Run the dye fuel pressure test with the HDS. If the HDS indicates normal, the high-pressure side passes and you move on to fuel quality. If it does not indicate normal, pause the P0172 path and handle the high-side fuel pressure fault path before continuing. After fuel pressure checks pass, consider the fuel. The chance of a fuel-related issue goes up if the rich condition appeared shortly after refueling. The MIL distance value in the data list, along with fuel level, may help with that call. For this step, turn the ignition off, drain the fuel tank, and refill it with known good fuel. Start the engine, let it idle, then drive under the same conditions where AFFB was 0, 79 or less. Engine speed, vehicle speed, relative throttle position, and accelerator pedal position. Watch AFFB on the HDS while driving. If AFFB is still less than 0, 79, fuel was not the cause, so continue. If AFFB is no longer below that point, the fuel was causing the low AFFB value. Next, check the MAF sensor reading under controlled conditions. Keep the engine idling and make sure ECT sensor 1 is above 158 degrees F, 70 degrees C. The transmission is in P or N for an automatic or neutral for a manual, and all engine and electrical loads are off. Monitor engine speed, then hold the engine at 2,500 RPM with the accelerator steady. While holding 2,500 RPM for 30 seconds, check the MAF sensor value on the HDS. For a /T, the range is 6,59, 1G/S. For M/T, the range is 5,57, 7G/S. If the MAF reading is in range, move on to the engine oil check. If it is not in range, inspect the air cleaner assembly for cracks, damage, or incorrect installation. If that checks out, replace the MAF sensor/IAT sensor. Now check whether engine oil contamination is influencing the trim. Keep the engine idling and gently pinch the PCV vacuum hose. With the hose pinched, watch AFFB on the HDS. If AFFB is still less than 0.79, the engine oil is considered okay for this diagnostic path, and you continue to the air/fuel sensor check. If AFFB is not less than 0.79 with the hose pinched, the engine oil is contaminated. Determine the cause of the contaminated oil, such as faulty injectors. Then replace the engine oil and oil filter. If the earlier checks pass, substitute the front air/fuel sensor with a known good sensor. Turn the ignition off, install the known good A/F sensor, start the engine and let it idle. Then operate the vehicle under the same conditions where AFFB was 0.79 or less. Engine speed, vehicle speed, relative throttle position, and accelerator pedal position. Watch AFFB while driving. If AFFB is still less than 0.79, the A/F sensor is not the cause. Reinstall the original A/F sensor and continue. If AFFB is no longer below that point, the original A/F sensor was causing the low AFFB value, so replace the original A/F sensor. The last component substitution in this path is the fuel injectors. Turn the ignition off and install known good fuel injectors. Start the engine, let it idle, and again operate the vehicle under the same conditions where AFFB was 0.79 or less. Watch AFFB on the HDS while driving. If AFFB is still less than 0.79, the injectors are not the cause. Substitute a known good PCM and recheck. If AFFB is no longer below that point, the fuel injectors were causing the low AFFB value, so replace all fuel injectors as a set. Keep verification separate from testing. After the repair decision is made, verify the repair and confirm P0172 stays gone under the same kind of operating conditions that made AFFB drop in the first place. The takeaway is simple. For P0172, do not guess at rich causes. Prove the trim fault, then work through fuel pressure, fuel quality, airflow measurement, PCV oil influence, sensor feedback, and injectors in order. For more diagnostic training, visit stepdiagnostics.com.